Ever gazed at the night sky and wondered, how long would it take to get to that red dot? You know, the one twinkling like a cosmic disco ball. That's Mars, our planetary neighbor, and the target of humanity's extraterrestrial wanderlust. It's a question that has captivated stargazers, scientists, and dreamers for centuries. Could we hop on a space shuttle and pop over for a weekend getaway? Well, not quite. While Mars tantalizes us with its rusty hues and whispers of ancient life, reaching it is no walk in the park, or even a drive to the grocery store. It's more like planning a cross-country road trip, but instead of highways and rest stops, we have gravity assists and orbital slingshots. The journey to Mars is a delicate dance between celestial mechanics, technological prowess, and a healthy dose of cosmic patience. So, buckle up, space cadets, as we embark on a journey to unravel the mysteries of interplanetary travel time. You've probably heard the popular refrain, it takes about 9 months to reach Mars. That's the estimate often touted by NASA and other space agencies, and it's not entirely inaccurate. But like any good cosmic riddle, the answer is a bit more nuanced. Imagine trying to throw a dart at a moving target while standing on a spinning carousel. That's essentially what traveling to Mars is like. Both Earth and Mars are constantly orbiting the Sun, each at its own pace and on its own elliptical path. This means the distance between them is always changing, like a cosmic game of tag. 9 months represents the average travel time for a spacecraft using current technology and a fuel-efficient trajectory known as a Hohmann transfer orbit. But depending on the launch window and the positions of Earth and Mars, the journey could be shorter or longer, like finding a shortcut or hitting unexpected traffic on your cosmic road trip. To understand why travel time to Mars is so variable, we need to delve into the cosmic ballet of orbital mechanics. This intricate dance of celestial bodies dictates the timing and distance of our interplanetary journeys. Earth, being closer to the Sun, zips around our star at a brisk pace, completing an orbit in about 365 days. This rapid journey means that Earth is constantly changing its position relative to other planets. Mars, being farther out, takes its sweet time, clocking in at roughly 687 Earth days for a single orbit. This leisurely pace means Mars lags behind in its cosmic journey, creating a dynamic relationship with Earth. This difference in orbital periods means that the distance between Earth and Mars is constantly in flux, ranging from a mere 34 million miles at their closest approach, known as opposition, to a whopping 250 million miles when they're on opposite sides of the Sun, a position called conjunction. These vast differences in distance significantly impact mission planning and travel time. That's like trying to plan a road trip when your destination keeps moving farther away. Imagine the challenge of calculating fuel, time, and resources when the target is constantly shifting. To make matters even more interesting, both planets travel in slightly elliptical orbits, not perfect circles. These elliptical paths mean that the distance between the planets can vary even more than if they were in circular orbits. This means their speed varies throughout their journey around the Sun, adding another layer of complexity to calculating the optimal launch window and trajectory for a Mars mission. Engineers and scientists must account for these variations to ensure a successful journey. Every 26 months or so, Earth and Mars align in a way that minimizes the distance between them. This celestial sweet spot, known as a launch window, offers the most fuel-efficient opportunity to send spacecraft to the red planet. It's like catching a cosmic express train instead of taking the scenic route. During these close approaches, the distance between Earth and Mars can shrink to a mere 34 million miles. While that still sounds like an astronomical distance, it's a far cry from the 250 million miles that separate them at their farthest points. This proximity translates to shorter travel times, potentially shaving months off the journey. However, even during these close encounters, the journey to Mars is no cakewalk. It still takes a significant amount of time, resources, and careful planning to traverse the vast expanse of space. And let's not forget the challenges of surviving the harsh conditions of interplanetary travel, like radiation exposure and the psychological toll of prolonged confinement. Section 5: Speed Demons versus Slow and Steady. Propulsion's impact on travel time. One of the key factors influencing travel time to Mars is the type of propulsion system used. The propulsion system determines how fast and efficiently a spacecraft can travel through the vast expanse of space. Think of it like choosing between a zippy sports car and a reliable but slower minivan for your road trip. The sports car might get you there faster, but the minivan offers a steadier, more fuel-efficient journey. Both will get you there eventually, but the experience will be quite different. The choice of propulsion system can significantly impact not just the travel time, but also the overall mission design and cost. Currently, most Mars missions rely on chemical rockets, which burn fuel to generate thrust. These rockets have been the workhorses of space exploration for decades. These rockets are powerful, but relatively inefficient, like guzzling gas on a long drive. They consume a lot of fuel, which means carrying large fuel tanks that add weight and complexity to the spacecraft. They can get us to Mars in a reasonable amount of time, but they require a lot of fuel, which adds weight and complexity to the spacecraft. This also limits the payload capacity, meaning less room for scientific instruments and supplies. However, scientists and engineers are constantly exploring new and more efficient propulsion technologies that could significantly reduce travel time to Mars. These advancements could revolutionize space travel. These include ion propulsion, which uses electricity to accelerate ions and create thrust. This method is much more efficient than chemical rockets and can operate for longer durations. Another promising technology is nuclear thermal propulsion, which harnesses the heat from a nuclear reactor to heat propellant. This could potentially cut travel time to Mars in half. And then there are solar sails, which use the pressure of sunlight to propel a spacecraft. This method requires no fuel, making it an incredibly efficient option for long-duration missions. Section 6. Space Travel 101. It's not just point and shoot. Traveling to Mars isn't as simple as pointing a spacecraft at the red planet and hitting the gas. It's a highly intricate process that requires precise calculations and careful planning. It's more like navigating a complex maze with constantly shifting walls. Every move must be meticulously planned to account for the dynamic nature of space. Spacecraft don't travel in straight lines. They follow curved paths dictated by gravity and orbital mechanics. These paths are influenced by the gravitational pull of various celestial bodies. To reach Mars, a spacecraft must first escape Earth's gravitational pull, which requires a tremendous amount of energy. This initial phase is one of the most energy-intensive parts of the journey. Once in space, it must then be carefully nudged onto a trajectory that will intersect with Mars's orbit. This involves precise calculations to ensure the spacecraft is on the correct path. This often involves performing a series of maneuvers, like adjusting the spacecraft's speed and direction, to ensure a successful rendezvous. These adjustments are critical for aligning the spacecraft's path with Mars. And it's not just about getting to Mars. It's also about arriving safely. The spacecraft must be in perfect condition to handle the final approach. Upon approaching the red planet, the spacecraft must slow down and enter Mars's atmosphere at just the right angle and speed to avoid burning up or bouncing off into space. This requires precise control and timing. This delicate maneuver, known as atmospheric entry, is one of the most challenging aspects of any Mars mission. Successfully landing on Mars is a testament to the incredible engineering and planning that goes into space travel. Section 7. Warp speed, please. The future of faster Martian voyages. While current technology limits travel time to Mars to several months, the future holds the promise of faster and more efficient journeys. Scientists and engineers are constantly pushing the boundaries of space exploration, developing new propulsion systems, and exploring innovative mission architectures that could significantly reduce travel time. One promising area of research is nuclear fusion propulsion, which harnesses the power of the sun to create thrust. Fusion reactions, the same process that powers stars, release enormous amounts of energy, potentially allowing spacecraft to reach incredible speeds. Imagine reaching Mars in a matter of weeks or even days. Other concepts include antimatter propulsion, which exploits the annihilation of matter and antimatter to generate thrust, wormholes, theoretical shortcuts through space-time that could connect distant points in the universe, and even warp drives, a staple of science fiction that involves manipulating space-time itself to achieve faster-than-light travel. Section 8. Mars awaits, a future of quicker cosmic cruises. So, how long does it take to reach Mars? The answer, as with many things in the cosmos, is, it depends. Factors like launch windows, propulsion technology, and mission design all play a role in determining the duration of the journey. While current missions typically take around 9 months, advancements in space travel technology hold the potential to significantly reduce travel time in the future. Imagine a future where we can hop on a spacecraft and reach Mars in a matter of weeks, days, or even hours. As we continue to explore the cosmos and push the boundaries of human ingenuity, one thing is certain. The journey to Mars, once a distant dream, is steadily becoming a closer reality. And who knows what wonders await us on the red planet, just a shorter and shorter cosmic commute away.